This video is for Pythagorean Theorem in 3D. So occasionally we're going to need to find the diagonal of a 3D figure. So what we've got to do with that 3D figure is draw a right triangle into the box. And so you can see that blue right triangle. There's the right angle. And so our formula for Pythagorean Theorem is a squared plus b squared equals c squared. But we like to simplify this down and go ahead and square root that side. So remember, your A and your B are your legs. Your C is always your hypotenuse. So your legs are going to be the sides that touch that right angle. So all you've got to do is plug and chug. So I could do 8 squared plus 15 squared equals C. And type that all into your calculator in one fell swoop. The square root of 8 squared plus 15 squared. And you would get that X equals 17. All right, on this next one we have a cone. So you can see our right triangle drawn in here. And so again, our formula is one of the legs squared plus the other leg squared, and that's going to give us our C. But in this one we can't use that formula because they have given us the hypotenuse length here. So when we're given the hypotenuse and we have a missing leg, we do B, which is our missing square, or missing leg, equals the square root of C squared minus A squared. So again, C is always your hypotenuse. So here my missing leg is X. My hypotenuse, or my C, is 5.4, and the leg that I'm given is 2. So if you type this in your calculator, you're going to get a long crazy decimal. So we're going to round it, we're going to approximate. And so if you type this in, the square root of 5.4 squared minus 2 squared, you're going to get approximately 5. The last shape we have is a rectangular prism. And these are some of the most difficult because you have to do Pythagorean theorem twice. You have to find the diagonal of the base and form a right triangle on the base. So that's the blue triangle. And what you want to do is you want to identify all your sides and the exact lengths that you're working with. So one of my legs is 8. It touches the right triangle here. And then this leg here is the same length as this side. So my other leg is 3. So again, my formula is leg squared plus leg squared equals the hypotenuse, and then we square root that. So here I would have 8 squared plus 3 squared, and that's going to give me my missing hypotenuse. So in this one though, I don't want to square root it just yet. I just want to do 8 squared plus 3 squared. And so 8 squared is 64, 3 squared is 9, and then if I add those together, I get the square root of 73. Now there's a reason for leaving it in this form, and you'll see why in a second. It makes your numbers turn out better. They're more accurate. So now my second triangle here is this yellow one, because what I'm actually trying to find is this length from the very bottom corner at the front to the very top corner in the back. And so this bottom leg here, this is the measurement that we found, the hypotenuse that we found earlier. And then this leg is going to be 4. So again, we have a squared plus b squared equals c squared. But again, we like to condense, so we go ahead and we do the square root of one leg squared plus the other leg squared, and that's going to give me my c. So my first leg is the square root of 73, and then we're going to square it. My second leg is 4, and we're going to square it, and that's going to equal x. So the reason I told you that we're going to leave it in the square root form is because an exponent of 2 and a square root sign cancel each other. So it just makes my math a little bit easier. So here what I would have would be 73 plus 4 squared gives me x. So if I do the square root of 73 plus 4 squared, my x is going to be approximately 9.4. And that's it for this video.